YMT217 programming languages. We are still discussing the evolution of the major programming languages, chapter 2. This is the third part. And in this part, we are going to discuss the first step towards sophistication, ALGOL 60, and computerizing business records, or the common business-oriented language COBOL. And now let me remind you with few key points that we always need to remember while discussing about the steps of the development of programming languages that we know today. The programming environment itself was extremely limited in its efficiency, reliability, in its memory, processing type, and it was not exactly standardized. Okay, so whatever people or developers designed and developed back then was somehow machine dependent. That time it was exactly totally dependent on the machine. It needed a machine to be built on. Now it wasn't, these machines were not the way we have them standardized. Every company was developing some certain machine based on its own view. Of course, there was a common view, but there was no exact standard. That's why the software was a machine oriented. Okay. Now, let's just revise these points that we need to think about while discussing things related to ALGOL 58. The first thing is there was Fortran. If you remember, around that time, Fortran, first version, Fortran 0 and Fortran 1 were exactly available, and people were still developing them until 60s. Yet there was Fortran, and it was also machine dependent. IBM machine 70X or the 70 version X, these series next to 70, okay, 700 something. That was the available machine which Fortran was designed for back then. All right. Now, one more thing. Machine and programming languages, as I said, they were designed for specific machines, not necessarily like just Fortran. There were other programming languages, but they were built around certain machines. They were machine specific or machine dependent. There was no exact concept of portable language, a language that fits any machine back then. That was also one of the problems in the environment or the environmental design around the programming languages back then. Also, the concept of universal language for algorithms, there was no such a thing. That is why the idea of algorithm programming language, or ALGOL, algorithmic language, came to existence. Initially, it was named International Algorithmic Language. Why international? I will explain now. But before I go further, now I just need to say these things. We have an algorithm. An algorithm, as you know, is a descriptive way for solving a problem. Okay, how about if we translate this algorithm to a code? Then we need a programming language to do that. So that was the idea of International Algorithmic Language, or actually it became next ALGOL, or Algorithmic Language, ALGOL. Now 58 was exactly the year it was agreed upon. ALGOL itself was made or laid out. Its own specifications were set by different teams from Europe and from America. That's why it's not a sole development of one team, and it looked for the universal perspective, the perspective of being international. That's why they tried to call it at the beginning international, then they just dropped this international concept, and the concept of universal, the universal concept remained there. All right, how about other specifications of ALGOL 58? Now they thought of Fortran. Fortran was there. How about if we borrow some concepts from Fortran? Yes, for sure. That's why we can refer to ALGOL itself as a descendant of Fortran. It borrowed from Fortran. But what was missing back then in Fortran? How about data types? Back then were not really available. They were not described fully, they were not used in Fortran. That's why concept of data type must have been developed before creating a whole concept of a language for for describing algorithm. One more thing, when we speak about algorithms, we need certain notation to be used. Means what? How about we need a mathematical notation to describe this algorithm, and we will come to it. One more thing, Fortran back then, I say not now, now it has all this concept. Back then was not having compound statements, so they thought of the idea of compound statements to be added to Fortran. How about some restrictions? How about if we solve some restrictions also from Fortran? The first restriction was the name of identifiers was limited in its length. It was limited to 6 letters. They removed this restriction while developing the concept. I say the concept. There was no exact language yet. In ALGOL 58, the layout or the design or the manual of the design itself. Also the dimensions of arrays, it accommodates for more dimensions. In Fortran back then only 3 dimensions were possible. Now this one removed that restriction. Also the lower bound of arrays in Fortran was 1 by default. This one removed this kind of restriction. Also the nested selection back then was not exactly formulated. ALGOL itself set it as a target. Now I understand, because I'm explaining these things, you say nested selection, it's a basic thing for us now. Back then it wasn't exactly understandable the way we look at it now, because we already know it. It's popular in our own scientific culture. Back then it wasn't. Back then was a new idea, like a genuine idea back then. All right. Who exactly proposed the idea of ALGOL 58 and the next versions or the successor versions? 2 associations. The first one is ACM, Association of Computerized Machinery, and the second one is GAMM, German Association for Applied Mathematics and Mechanics, right? And these met and laid out all the goals that they were looking for. These are just basic goals. There are so many others. But among these basic goals, or let me say not basic, the essential ones. Okay, the essential ones that a language cannot be set without those. It should be the language that they were designing or looking for should be close to mathematical notation. So they needed a mathematical notation for representing algorithms. And remember this one because it will come with us very soon. Also, they needed a good way for describing an algorithm. While you need to describe an algorithm in a programming language, you need a good way for that. So you need to accommodate for a good way for description in this case. And should be also translatable to machine code. Of course, this is, an essential need cannot be tolerated. Otherwise, what's the benefit of such a language, right? So as I said, while they tried to come up with new additions to Fortran, also overcome the whatever maybe drawback or problems were available that were not actually going along with the concept of ALGOL itself. So initially they created the data type. In Fortran back then was no real data type available. They formulated it in ALGOL 58. They also allowed for longer named variables or names, in this case also identifiers. They allowed arrays to grow in dimensions. They created the parameters and they gave them like separate modes for in and out. Use of subscripts for arrays, like they provided the bracket concept. The compound statement was formed by begin and end. Now, as I said, it sounds like maybe, I'm sorry to say, maybe stupid, like to us. What's big deal? We can create a compound statement by maybe brace, maybe marking beginning label and end label. Well, to us now is easy. We are familiar with the language. But back then, or the concept of programming language, back then wasn't. this is exactly why we are studying it, how it came to us after this long struggle of stages, like we learn this concept. Also inventing the semicolon to be used as a statement separator. Now we are familiar as with this in Java, for example. You guys studied Java. You use the semicolon for terminating a statement. Back then it was used for separating statements. Also the assignment operator. The assignment operator is very similar to the one we use today, equal, the equal sign. But before it there was a colon. The initial one, or the initial version of the assignment statement, was using equal, then greater than. It was dropped, the greater than was dropped because it was really hard to be translated using punch cards. Back then they were translating the language manually and they were using punch cards. So it was not really that much convenient. They use colon equal. Also they added something else if in the if statement, the structured compound statement in this case for conditional. Now, as I said, it sounds to us like extremely primitive. What is a big deal about if, else, if? Well, no big deal about it now. Back then there was. All right. One more thing. Since the programming language that was planned to be developed was not meant to be machine dependent, then they omitted anything related to input and output. Why? Now, machines back then were not exactly standardized. There were different companies leading in the world in computerized machines, and they created their own, let me say not standard, their own series of computers. And these series were not following one unique standard worldwide. There was no such concept like the machines, the computers that we use now. You set up whatever the operating system that you are dealing with, and then you download the programming language that you want to program with, and then you just use it based on the operating system. Back then there was no such thing. Every company that was leading in machine production or computerized machine production had its own standard or its own steps for use for the use and for the development of these computers. That's why they omitted the input and output, because they were really machine dependent. And the whole concept of ALGOL itself was built around the idea of removing or dropping anything related to the machine and makes the program machine dependent. All right. So the early time of ALGOL itself, which is 58, was not implemented. They just set up the rules for it. But some of, you can say, organizations or like universities, for example, Michigan University created what they called Michigan Algorithm Decoder. This is a variation of ALGOL 58 for their own use. Also, a developer created his own version, Jovial, Joule's own version of International Algebraic Language. He created another variation of ALGOL for his own development. They were not that much popular. They were used for their own, actually, applications back then. Now, one thing I would really like to highlight, IBM was extremely popular, maybe the most, I would say the most dominant in computer industry back then. And for that reason, they didn't exactly support the machine IBM series, the one that we know like 700 series, 700X series. And for that, IBM was not exactly encouraged to support this programming language. It's not meant for its own machine, so they didn't support it. And look at it. Now, if a famous computer or a famous computing company that is not supporting a programming language, then most likely this programming language will not be that much popular. Why? The popularity gained, for example, Fortran gained that huge popularity. Why? Because of IBM was itself popular. It's not because Fortran is better than ALGOL, for example. No. It was because it was adopted by IBM itself. It was IBM dependent, and IBM was extremely popular back then. Fortran gained its own popularity along with it. All right, so that was the initial version. It was not implemented. They came up with the idea of an improvement of 58 and creating 60 in around 60s time. That's why they called it 60. And again, like different meetings, and they came up with new features. What kind of features? Well, local scope. You guys are familiar with the local scope and global scope. Also, the use of two parameters, not only just one type of parameter, passing by value, passing by address. Also, the use of recursion in subprograms. Also, the use of stacked dynamic arrays. We'll speak about those later. I mean, the stacked dynamic array, not now. But still, again, they kept input and output dropped. Why? Because it was fully machine dependent back then. All right. ALGOL 60 was successful in different ways, and it was unsuccessful in other ways. Let me just brief the few points that it succeeded with. First of all, it was the only way, which was a standard back then, to publish algorithms for more than 2 decades, for over than 2 decades. That means what? The only way, if you are trying to publish an algorithm and you want to write it in a programming language back then, 60s time, 70s time, you have only one way to do it, which is the ALGOL 60. Why not Fortran? This one was much better back then for that specific purpose. One more thing, all imperative languages came next. Imperative languages like C, C++, C#, Pascal, many other languages came next, borrowed from ALGOL. They based a lot of things based on ALGOL's design. Okay, one more thing, ALGOL itself provided something that we are still using until even today. But the idea maybe will come with us while we were explaining, but before that, let me tell you about the whole concept. I said about mathematical notation. Mathematical notation means what? We formulate whatever algorithm based on its own background mathematics. Okay, we need for that a formula or a forming type. The formula used back then, or the form used back then, was BNF, or Backus-Naur form. It was a formula or a form used for describing algorithm in mathematical notation. Back then, it was the only language used this kind of notation to define algorithm in its own syntax. It was also the first language to be machine independent. And there are so many, actually, a list of first machine language, first programming language. There were so many with ALGOL 60. And that's why if you study ALGOL 60 in many ways, you'll find it the first in many things. But these are the most popular ones. It was the first machine independent. We said the whole idea was about creating a universal concept for algorithm programming. Okay? So that was the case. Now for the problems or disadvantages showed with ALGOL 60, the first one is it wasn't popular. I said the main reason was exactly it didn't adopt one type of company that was popular back then. As I said, Fortran, for example, became popular because it was adopted by IBM. It was used for IBM itself. IBM gained its popularity, Fortran followed. That doesn't mean Fortran was useless or still used. No, it's even still until today, people are still using it, and it was really useful. And it has been useful ever since. However, ALGOL itself is really useful. It was useful back then, and it's still useful now, and you can even program with it. But it did not exactly adopt a machine that made it popular back then. This is number one. Number two, imagine you are programming with a language that does not allow you to use or properly use input and output. What kind of useful machine language is this? That's a problem. Okay? One more thing, it was not exactly portable. The set of characters used back then did not make it exactly portable. One more thing, the ALGOL itself, designed based on allowing easiness of use, or flexibility in other words. When you want to create something easy to us human beings to use, then that means it will be hard to the machine side. Why? The easier it comes to our side, in most cases, it becomes hard for the machine to implement it. So too flexible, hard to implement for the machine. One more thing, why it did not become popular back then? Well, Fortran was gaining its popularity right about the same time. So just about the same time with ALGOL, Fortran was becoming popular back then. So it exactly shaded ALGOL. As I said, the BNF used for describing algorithms was really odd and complex back then. It is extremely neat and nice now, but back then was odd for programmers. That was also a problem or a disadvantage. And as I said, on top of all, it was not supporting IBM, the most popular back then, or one of the most influential companies in computer industry back then. It did not make it that much popular. Okay, the business-oriented language or common business-oriented language, COBOL, is a computerized business records or used for such scenario. Now we spoke about scientific. Whatever languages we described before needed for scientific use. How about business? Around 60s time, early 60s, mid 50s, around that time, popularity in business using computational power came to existence. So big companies tried to use computers in their own business, and for that they needed a software package to allow them to use the power of machines. And for that reason, they started formulating something similar to business-oriented language, not COBOL yet. But let me tell you about something extremely important about COBOL. COBOL itself was not exactly influential to other languages, except for Programming Language 1 or PL/I. Why it borrowed a lot from it. Other than that, it was just one oriented business-oriented language, and it was adequate enough by itself. So that people did not really need to create another developed version of it or another variation of it. So they just used it and they kept using it. Even today, you can use it for business-oriented tasks. That's why COBOL was not that much influential in other languages, although there are a few things that we learn from COBOL and use in other programming languages, and we will see how. How about the environment used for development or available for development back then? Now, here's the thing. There were different departments or different organizations using their own packages, specific packages of software for business use. UNIVAC itself, computer, this universal automatic computer, was actually using or began to use something called Flowmetic. So for Flowmetic is a software programming language, is a software package, it's a programming language used for business. Also, the Air Force of the United States used something called AMICO, which was also a software package meant for their own business. IBM itself created its own commercial TRAN or commercial translator, COMTRAN. Like Fortran, the same concept. Instead of Fortran, formula translating or formula translator, this one is commercial translator. It's like a translator for commercial use or business use. But it wasn't enough. Why? Because they were too much oriented to their own machines or the machines that they were meant to be built around or on. Now, how about Flowmetic? Why we are discussing the Flowmetic? This one was actually too much influential for COBOL itself. So let's see the features of Flowmetic itself and see what COBOL came to provide more than these features or how it improved these features. There were names up to 12 characters. Maybe now you say, what do I need to do with 12 characters? In business, you may need even longer than that. And at the beginning of, for example, Fortran was limiting the names of variables, names of identifiers to only 6. That was not enough. So it was possible with hyphens. We could use hyphen, like maybe first name, hyphen, second name, or so on. And also it allowed English names for arithmetic operators. Instead of using, let's say, plus as a sign, we could just write plus. I'm just giving a simple example. It's not exactly like this. But there was no operators like that. They could be written in English directly. And there was a separation or distinguishing between data and code itself. And the last thing, and this is the thing that I said we are still using today, it suggested the use, and was also using it within its own programming style, a verb at the beginning of the statement, like do something, define something, okay? That was the initiation of this kind of usage. These things were adopted by COBOL and implemented and actually improved and then implemented. Again, COBOL itself was created as a joint groups, but they were led by the Department of Defense in the United States. And I will say why I'm saying about it, why I'm referring to the Department of Defense of the United States. I'll say in just a few minutes later, okay? Now, for COBOL itself, what was the goal, or what were the goals behind the whole implementation, development, not implementation? If we have this Flowmatic, how about we use it? Well, it was not exactly adequate or enough. So there must be a language that looks like simple English in its own presentation. Why simple? For commercial use or business use, we do not expect people to have a high scientific knowledge in programming. They wouldn't know the jargons we use from the technical background and so on. So it was meant to be simple so that those who use it in business sect understand what it is written in it. Also, again, the same thing, simple in English, like presentation, and easy to use. Again, it should be enough simple to be written and enough simple to be used. One more thing I would like to highlight here, written in English. Back then, and now maybe you say, oh, well, all high-level programming languages are written in English statements, right? But back then it wasn't exactly the case. They were using more likely mathematical notations, not exactly instructions the way we see them now. It was even odd to people to think about a simple English language written programming context or syntax to be understood by a machine. That was odd back then, but to us is extremely familiar, okay? So again, easy to use. It was easy to use, or when you want to design something easy to use, again, either it will be complex in its implementation, or it will be less powerful. So you have to give up something. This is like a compromisation issue. If you want to make something too flexible, it will be too complicated to the machine side if it is too flexible to our side. Or it may be flexible to our side, but less efficient, okay? So you have to compromise between those or along with those. Also, they needed to target a lot of users. Why gaining popularity in one language? Programming languages back then were extremely popular. Popular means what? The whole industrial background of programming language became, you can say, what by our concept now, viral. Back then there was no concept of viral, I mean, as an event, but back then it was really viral, like maybe like applications now. A programming language, make a programming language, create a programming language, develop a programming language, or improve a programming language. So they were targeting more users so that they can guarantee the popularity of the language. Otherwise, it would just be vanished or shaded. People would not be used will not be using it. One more thing, they thought about compiler problems, the available compiler problems. How about if we avoid having these or getting stuck with them? So the programming language itself should not be biased by these problems. All right. Now, as I said, the design committee got stuck with a lot of things. Now, just one simple example: the arithmetic expressions, how they would just formulate them. This is one of the examples. Also, the subscripts. There was a debate about the subscripts and how they use them. Like, some of them said that this is too complicated to be used, and so on. There were so many, fights or debates over these things. How about the contribution of COBOL? Contribution of COBOL, the first thing, as I said, it provided the concept of starting a sentence by a verb like define, do, etc. This initiated the concept of macro facility for high-level language. Also, the hierarchical data structure, the records, proposing the hierarchical data structures like records. Now, to us, well, we know hierarchical data structure is not weird. Back then, it was weird and it was new. Also, the nested selection of statements, it came in business use for sure. Long names, up to 30 characters. Back then it wasn't possible, but COBOL brought it. You see here only 12 characters, and that was really long. Okay? But it was used with hyphens. Again, the concept of separating data or data division itself came with COBOL. COBOL itself is still used, by the way. If you want to learn it, it's really not a hard language, and it is widely used in business, not in just scientific stream or technical stream, but it's still available. I mean, it's not like vanished and gone. No, still there. Now, one thing, what made COBOL popular and ALGOL not popular? Remember, we said ALGOL itself was not adopted by any influential company or body. Unlike ALGOL 60 or ALGOL itself as a concept, COBOL itself was adopted by the Department of Defense. And I said, remember when I speak about it, now Department of Defense, I said, remember it's a key word in this context. Why? It made it compulsory, mandatory. All those who are affiliated with the Department of Defense of the United States back then were supposed to use COBOL. It was mandatory by the department. So it became popular. When a lot of people use it, compulsory use certain language, back then programming languages were not that much popular, then people get used to that language, they transfer it to others, it became popular. Okay? Still, until today, it's still widely used in business applications. It is really not that much difficult. Even those who are not from the scientific stream can learn it and use it. And that's actually the end of the session for today's session. We have a last session for this long chapter. Actually, this chapter is really long, but it guides you about the concept of development or evolution in programming languages. Until the next part of this chapter, have a good time. Goodbye.